Alright, this is the outside to processing user in. As you can see, the processing microcontroller is connected to a button with full resistors, and this button brings it to ground. And when the button is pressed, the processing reads it and turns the light on or off. This test passes. Alright, this is the processing to microphone DC power. The current is set to the maximum of 200 milliamps and the maximum VN of 5.27. Down here, you can see that the load generator is connected to the 3.3 volt out, and 3.3 volts is being seen. This is going to the microcontroller, and the maximum current draw from the microphone is 5 milliamps. Testing for 3 seconds, and it is able to provide 5 milliamps for more than 3 seconds. So this test passed, and the current for those 3 seconds was 37 microamps, which is below the peak current for the processing blocks, and this test also passes. This is the processing block I nominal. The voltage of 4.5 minimum and maximum current of 200 milliamps going to the processing block.
It's supposed to be 0.
And monitoring for 30 seconds. Alright, this is the processing to microphone DC power. The current is set to the maximum of 200 milliamps and the maximum VN of 5.27. Down here, you can see that the load generator is connected to the 3.3 volt out, and 3.3 volts is being seen. This is going to the microcontroller, and the maximum current draw from the microphone is 5 milliamps. Testing for 3 seconds, and it is able to provide 5 milliamps for more than 3 seconds. So this test passed, and the current for those 3 seconds was 37 microamps, which is below the peak current for the processing blocks, and this test also passes. This is a test of microphone to processing ASIG. The function generator will be providing the frequency range, DC offset, Vmin, and Vmax. Alright, as you can see, the frequency is 1 kilohertz, the maximum is 3 volts, and the minimum is about 500 millivolts, which is below Vmin and above Vmax for this component, and it is properly receiving the signal and displaying it on the matrices. I will now increase the matrix for the range.
I need to show that I'm getting it. Okay? And then I do whatever I'm going to do in here.
Okay, 2 kilohertz signal, 2 kilohertz signal, also receiving, 3 kilohertz, 3 kilohertz, 4 kilohertz, 4 kilohertz,
Okay?
5 kilohertz,
And this is this code right here. And this is just a pass through.
and 6 kilohertz.
Sending it to the app.
And the
Okay, well,
Vmax
show that you're getting
is
data.
3, and Vmin is
What you're getting is you're getting
0.6,
data.
which is
You're
still
getting
below
this data
Vmin of 800 millivolts and above Vmax of 2.4 volts. And it is properly receiving the input. So this test passes. This is a test to verify the C++ property for the code processing data and the maximum file size. So running the command make It is making the build, and as you can see, the ARM none EBI G++ was used for all of the commands, so it is a valid C++ file. And the output file size for the hex is 46 kilobytes, which is below the maximum of 768 kilobytes, so this test passes. This is processing to matrix controller data. As you can see, the oscope is on SPI, and currently one LED is going to be displayed. That command is going to be sent every second. Plugging in the microcontroller now. Okay, watching the data as it comes in. It's collecting one. View the event table. Oh, that one was a little quick. Okay, there. And you can see that there's 16-bit messages coming across in binary. This test passes. Alright, this is processing to matrix controller data, showing the logic level low and logic level high. The digital input is being probed currently, and you can see it on the screen. And the cursors are being used to measure the voltages, which has a minimum voltage of 0 and a high voltage of 3.3, which meets the requirements.